Welcome back. This is an Aleks training video on predicting deviations from ideal bond angles. If you have something that is completely trying to stay away from each other, exactly equally the same thing, three things coming off of a central atom, this will be 120 degrees. Okay, you can guess it because they want to stay away from each other as much as possible. If one of these is a instead of an atom, if one of these is a lone pair, the lone pair has a little bit more push than an atom does in terms of the electrons pushing other electrons away. So for instance, if you were to have something like a double bond, okay, where you're going to have a double bond is going to squeeze these two guys together just a little bit more, okay? So this is going to be greater than 120. So it pushes it just a little bit away. If I were to have this as a lone pair, this is this lone pair, this is going to be squeezed together a little bit more, just like this one. So this away from whatever it is away from the lone pair is going to be less than 120. It's going to squeeze it away. If you were to have two lone pairs, okay, so like water, where you have two lone pairs, it even squeezes even further. Okay, do you see? So it's one lone pair would squeeze it a little closer than 120, and then two lone pairs would even squeeze it even further than 120. All right, so what we're looking here is what is ideal, what is perfect, and then what are you really going to see? Is it going to be a little bit more than a certain angle that you expect, or a little less than a certain angle that you expect? So the example they're giving us right here is water. So we need to know what's the central atom of water. I've got two hydrogens and an oxygen. I would imagine that it's going to be the oxygen. So let's make a water molecule. We've got oxygen here, okay. I've got, I remember that this is bent. Why is it bent? Let's find out how many valence electrons we have. Oxygen has 6. The hydrogens have 1 each. Okay, so that's 8. So here is 1, 2. So this is 4 pairs. 1, 2. I need 2 more. Well, these are lone pairs, and they're on the oxygen because the oxygen needs an octet. So I've got 1, 2, and 3, 4. All right. Well, how many electron groups do I have attached to my central atom? I've got 1, 2, 3, 4. So if I have 4 groups, I'm going to have a tetrahedral. Okay, so I'm going to have a tetrahedral where this guy is coming out of the board, okay, and that guy is in the back, okay? So it's three-dimensional, where all of these angles, every single angle, no matter how you flip it, it's like a jack. I think a jack is a tetrahedral. However you flip it, it'll be exactly look the same in your hand. The top can be any one of the points, okay? So this, if you look it up in the book, I believe is 109.5. Okay, the tetrahedral is 109.5 degrees. But what happens if one of these are, if they're not all atoms that it's connected to, but in this case, like in water, you're going to have, this is hydrogen, okay, hydrogen here, this is hydrogen here, and this is a double dot, and this is a double dot. These are lone pairs. What's going to happen? Okay, now you can kind of see it. One is in the board, and one is sticking out of the board, and then these two guys are lone pairs. These lone pairs are going to squeeze this together. All right, so ideal would be 109.5, but these two sets of electrons are actually going to squeeze it even more. Okay, so let's answer the questions. What is the central atom? Okay, well, the central atom was oxygen. Okay, central atom was oxygen. How many lone pairs were around the central atom? So we had 2 bonding pairs to hydrogens, and we had 2 lone pairs, okay, 2 sets of double dot electrons. So that's 4 things coming off, so that's going to be tetrahedral. What is the normal angle for tetrahedral? You'd have to look it up. It's 109.5 degrees. What would you expect, compared to the ideal angle, what would you expect the actual angle to be between the oxygen-hydrogen bond, the oxygen-hydrogen bonds to be? So here's an oxygen-hydrogen, and here's an oxygen-hydrogen. Those 2 arms. Would it be 109.5, greater than 109.5, or less than? And it's the 2 sets of lone pairs that are having the influence. Okay, it's going to be less. It's going to be less than. It'll be smaller than normal because those electrons are going to be having more of an influence or a push on it than it was. Okay, thanks.